I wanted to record this to demonstrate the ways you can use AI tools like ChatGPT to help you with your medical research, audit, data analysis. I've been playing around with a new tool that I've come across called Code Interpreter this morning, and I was blown away by what it can do. And so I thought, rather than keep doing that on my own, I want to show you all what it can do, to see if this is something people would be interested in seeing more about, and also whether you got that magic feeling when you see what's about to happen. So I'll go through some basics, but really this is just designed as a sort of me playing around with a data set that I've got to show you an example of how it works. So let's get started. I'll come back to the ChatGPT interface, but first I want to show you the data set that I'm working with. And I imagine this is quite similar to the sort of data sets you'll all be pulling out or gathering as part of your clinical research, audit, whatever you need to do in the hospital. And I want to show what you can do with tools to try and speed up and improve the quality of the analysis you do. So this is a data set of patients who've had admissions to hospital with a stroke. And one of the questions we've been asking is how many of them get heart rhythm investigations before they go home. What investigations do they get? And what happens as a result of that? So this is a data set of patients, the diagnoses, as you can see, what their ECG showed, and also after trawling through a number of data sets, some of the colleagues that I'm working with on this project have managed to find data about whether they had Holter monitors, whether they had Zio patch tests, whether they had ILRs, and echo scans, things like that. So this is all a large column, and I guess the traditional way that I would normally interpret this is import all this data into something like SPSS and try and have a go at doing various statistical tests with it there. But I'm just going to show you now. Let me just save this as stroke cardio anon. What you can do using ChatGPT Code Interpreter. So I'm not going to cover how to log in and sign up for this. Hopefully you'll be familiar with that, and if it is something people want to see, I can come back and do that. But I'm using the plugin Code Interpreter here. So if you hover over the GPT-4 button and scroll down, you'll see a number of different options, and I've activated the Code Interpreter button, and when you do that you see a plus sign comes up, and that gives you the option to upload a file. So if I take the CSV file that we were just looking at, stroke cardio anon, and drop that into the box, it registers there. And then you've got to type your instructions. Now, to save us time here, I've pre-written out the instruction that I'm going to put in, but let me go through it with you. So what I've done is I've said the background to this data set is patients admitted to our hospital with a stroke. We're exploring how well patients without AF are managed and what tests they have, in particular looking at how many Holters, how many of Zios, how many of ILRs, and we're looking at other things like their CHA2DS2-VASc score, management and echo result. So that's written as if I was talking to a colleague or my supervisor about what I propose to do. So really talking to it as a person. Then I go into the data a little bit. I say that the way that I've set it up is that in columns from L onwards, they're suffixed with the tests that they represent. So what that means is just so that the model will know what tests are being referred to, I've put a suffix of what the test type is that each column is referring to. So here, rather than just saying date requested, duration, report date, I've written Holter at the end. And same for the Zio, date requested, report action, blah, blah, blah. Same with ILR there. So this way that the data headers are a bit more clearly labeled so that the model knows what I'm talking about. So I've said that the headers are fixed with the suffixes. Then I've asked it what I want it to do. So can you summarize what this data table shows? So I've asked it to calculate the total number of unique patients, calculate the mean and standard deviation for continuous variables, age, calculate the count in each category of the categorical variables. So e.g. Gender. I think that's what I referred to it as in the special. Yeah, gender. Then review the labels in discharge diagnosis, which here is things like, cerebellar infarct, LMA infarct, seizures, whatever, the different diagnoses that were given on the discharge letter, and rationalize and relabel them as appropriate. So for me, left and right doesn't matter, location matters, e.g. MCA and cerebellar, and then produce a table of counts for this, discharge destination, ECG finding, etc. So for the continuous and categorical data like age, gender, I'm thinking about what I want my data output to look like. So I'd like a nice table, as you see in good journal manuscripts, of age, mean and standard deviation, sex, what the count is, and characteristics like that. And similarly here, for the second part of my instruction, I've said, please give me a table of counts. And I've asked it, and I don't know if this will work, to try and actually look through the contents of this Excel spreadsheet and try and rationalize the written text there, because it's not put into neat categories. It's been free written by the discharging ward team. So let's see if it does that. Then I said, let's look at the test suffixes. Tell me how many patients without AF, so based on the ECG finding column, it'll determine if they've got AF or not. And tell me how many of them have had the various tests requested. And please give me the results of the data table with a summarized list of the results. Again, I'm going to try this out. I don't know what will come out. Let's see. And then, just as a sort of open-ended question, please mention any other interesting findings, suggest any correlations to look for, or any possible trends to analyze. Use Python where needed to do any analysis. Right, so fingers crossed, let's hit send message and see what happens. Okay, so what it's saying is it's loading the data set, looking at the first few rows to understand the structure of the data set. So in the way that a human would, it would look through the data set to see what's going on. So let's see what it's actually doing here. Okay, so this is the Python code that it is running to analyze this spreadsheet. So if you have a program that can run Python scripts, this is what you could run in it to do the same analysis. But here, the code interpreter is running this on its own. So it's importing the data, pulling in the file, renaming it, and then printing out the headers. And this is the sort of thing that it's looking at, and it's basically analyzing the data. So, okay, fine, I've seen this is the name of all the different columns, blah, 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 and it seems to be looking through the different titles. And then it looks like it's giving us an interpretation of what it's seen. The data set contains information about patients admitted with stroke. So I guess it understands the instruction that I gave it at the start. Here's an overview of the steps we'll take to analyze this data. Fantastic. So, if you ever need to demonstrate your methods or understand what is being done, it looks like it's printed this out for us here. So it's hopefully going to give us summary statistics. So total number of patients, mean and standard deviation of continuous variables, count for stuff like gender. It'll review labels and relabel stuff. So, that thing I said about rationalizing the text in there, and it'll produce a table, then it'll analyze the tests and tell us any other findings that it thinks are important. So let's start with step one and summarize the basic statistics of the data set. So step one was this, the summarized statistics. So summary statistics, this is what it's running again in the Python code. It's looking at the demographics, gender, stuff like that, and I guess it's testing its own results. So again, this is not completely neat, but let's see what the final output of it would look like. I suspect looking at this data, that's probably the age, mean age and standard deviation. The 179 is probably the total number of patients. That sort of fits with the number of rows. And then it's got me the number of male and female patients here. Oh, great. So it has produced it as a summary table here. Total number of patients, age, gender. Lovely. It says there's some incorrect values in gender, so we should investigate this further. Great, fine. So if I go back, let's see what it could be talking about. Okay, so I guess here at the end, what I've done as a mistake is not taken out some of the summary data. So it looks like some of that data has previously been calculated on this Excel spreadsheet. So ideally, we would delete this and run it again and then avoid that issue. So next we'll proceed with reviewing the labels and discharge diagnosis. Okay, so this is the thing about relabeling the text there. So let's see what it thinks it's going to do. So it's made a function, something called rationalized diagnosis, and what it does is it pulls out the word left, pulls out the word right, removes that to keep the diagnosis. Yeah, so it looks like that's all it's done. So it's taken the instruction that I've given it. It doesn't really come up with its own ways to rationalize it. So far, it doesn't show any evidence that it's looked at the data and made an educated move of how to clean that up a little bit. It's just doing the thing that I asked it to. Great. It seems that we've encountered an error due to some missing or non-string values in the discharge diagnosis column. Let's first identify these missing or non-string values and handle them accordingly. Okay, so it's told me that there's been an error in the data. Let's see what it's saying. Okay, so that means that there are some nan is Python code for a blank or not usable data. So if we go back, and you can see here what it's probably referring to is these cells here, which have got no value in them at the bottom. Okay, so it doesn't know what to do with those. It appears there are several missing columns. We can handle these by either removing the rows with missing values. For the purpose of this analysis, we'll assign the label unknown to the missing entries. Fantastic. That can do for now. So again, this modified the code to attach the phrase unknown to those diagnoses. So let's see what it comes out with. Discharge diagnosis. Oh, this looks like there's a network error. Let's see if I hit regenerate what it will do. Okay, it looks like it's starting from scratch again, but let's go back to what it was previously doing. Maybe we'll come back to this in a second. So it looks like it had rationalized the labels and counts, and it had said there are 126 infarct cases, TIA cases, midbrain stroke, unknown, other diagnoses. So okay, maybe that rationalization was a bit too much here. Okay, so let's see what it's doing with this part 2 here. It looks like it's running it again. That's probably because there was a problem with my internet halfway through. Okay, so it now seems to be up to the stage which we were just at, which was handling the discharge diagnosis, the ECG findings and things like that. Let's have a look and see what it's doing. Okay, so this time it seems to have taken a much more nuanced run, and this is one of the really interesting things, that if you run a model like this, you might see it interpret it in different ways when you rerun it. So this is really interesting. Let's see what we get with this time. It looks like it's interpreting what the shorthand is from that code, and trying to make a sort of categorization system for it. And it's doing the same thing for the ECG findings here. So this is much more useful actually. So discharge diagnosis, it tells me what's an MCA infarct, PCA infarct, ACA infarct, cerebellar infarct, frontal infarct, and discharge diagnosis, it tells me how many patients have been discharged to other hospitals. In the ECG findings, it tells us the counts, so how many patients have sinus rhythm, new AF, paced rhythm, and atrial flutter. Perfect, that's the sort of stuff we would want to present in any write-up of this work. It says, please note there are some anomalous entries in the gender. This is probably that same thing that we were talking about with the summarized statistics at the bottom. Good. So it says, now let's look at the columns with test suffixes. So this is the _Holter, _Zios, _ILR section. It says it's going to summarize the results of this test. Let's see how it tries to do that. So first of all, great. Like I said, it filters for the patients without AF. So it'll look in the ECG finding column and remove any patient that has the word AF as the result there. It'll then identify the columns to test. So it'll look for columns with the words requested or report in. And great, it tells me how many patients have had have values in these results. Okay, and here's the outcome. Holter, 17 patients. Zios, 28 patients. ILR, 0 patients. Echoes, 86 patients. Contrast, 0. Bubble, 8. This was okay. We need to investigate further to understand why there's a discrepancy between the number of requested tests and the number of reported tests. It's also worth noting that no ILR or contrast tests were requested for these patients. Great, and I think that's one of the things that we were suspicious of, and is definitely an important finding from our analysis of this data. Regarding the summarized list of results for each test, could you please clarify what specific information you're interested in? For example, are you looking for a summary of different types of results? Based on the current findings, one interesting trend to analyze could be relationship between patient age and type of stroke. Another could be correlation between type of stroke and ECG findings. Interesting. Okay, fine. So let's see if we can talk to the model and get it to do a couple more things. So let's say, please output tables as downloadable CSV files. Give me the summarized demographics and discharge diagnosis ECG findings to view in the CSV. Then I also want to think about what to do with that second paragraph. So what information am I interested in? I am interested in how many tests were requested for the cohort. Please produce a table of this. Let's just make things a bit easier for it. And also give me the percentage of the total cohort. Can you summarize also the types of stroke seen in patients with AF versus without? Tell me the percentage of the cohort of the group for each label. So again, what I'm asking it is there a difference in the types of strokes in patients with AF versus without? Again, our data set here is very small, so I'm not really going to rely on the results here for any sort of statistically significant findings, but let's see if it can do it. Let's just reiterate something again. I'm being a bit repetitive. Produce the results as CSV tables to download. Run. Okay, great. So it tells me it's going to make 4 CSV files, one of the summarized demographics, one of the requested counts, one of the stroke types in patients with AF, one of the stroke types in patients without AF. Okay, so ideally, perhaps the ones with and without AF would be put together so I could look at them comparatively, but that's something that's easy enough for us to do here anyway. Okay, so the first table, let's see what it's doing. Again, this is behind the scenes looking at the Python code that it's running to produce that table for me. Okay, so it's recognized that it's made an error. It says, I made a mistake in attempting to create a data frame from a series of different lengths. Okay, to correct this, it'll create separate CSV files for each summary. Okay, let's see. Let's start by creating a CSV file for the demographic summary, including the gender counts, etc. Okay, so age, gender, looks like it's okay, fine. So this is not ideal. It looks like it's producing separate CSV files for each result. So that will be something we probably do need to feed back in. But for now, we've got them here as downloadable files, and we'll look at them in a second. Now let's look at the CSV files for discharge diagnosis. Again, here it's produced each one as a separate CSV file, so not ideal, and we probably would need to look at that, about combining that. But our data is here. It just requires a few extra clicks, so maybe I'm just being lazy. Then it's looking at the test requested counts, and it's produced that in one table. Great, we would definitely want that all together. Now it's going to summarize the type of stroke seen with and without AF. So This is the interesting novel bit. Let's see how it handles that. It seems to have run some code. It made a group of patients with AF and told me how many they are and what percentage they are based on the discharge diagnosis. No, sorry, it's counting the types of strokes in discharge diagnosis for patients with AF. And it does the same thing for patients without AF by excluding that group of patients. It then makes a data frame for me and then produces a CSV count. Lovely. Here they are to download. Okay, so it says, thanks very much. Feel free to ask if you need anything more. Let's have a look at some of our findings. Gender summary, age summary, discharge diagnosis summary, discharge destination summary, ECG finding summary, test requested summary, stroke types. Okay, now let's see what these look like. So let me bring them through. Fine, so let's start with the age. Yeah, again, right, so here's our result, 67 plus minus 14. Great. Ideally, it would be in its own standalone CSV, but it's quite easy for me to copy and paste from the gender CSV we just got and try and have everything on one page. But I can sort of understand why it can't put that in one table, because it doesn't know how we want it arranged. So age, gender here, great. Let's see. Let me now pull the diagnosis summary. I'm just going to copy and paste from all the different CSVs, so you've got them all here together. That's from the discharge diagnosis. Let's look at ECG finding. Great. It's also got discharge destination, which is great. I'll bring that over in a minute, but here's our ECG findings. And again, what it's done is it's seen, I imagine the 18.1, 19.11, if we go back to our original data set, is an error on my part, because I bet what I've done is right at the bottom, not excluded the summary data, which it's tried to categorize for me. So, not its fault, fault of ours. Okay, what other data has it spat out for us? Let's have a look at, yeah, fine. The test requested summary. Okay, so it's made an error here, and we'll need to go back and have a look at it, because as you can remember, it did actually calculate for us here the number of tests that were requested, but it's clearly pulled across some incorrect information into the CSV file here. So no worries, we'll come. That is something which I would ideally come back and troubleshoot, but for now, let's see if I can. Okay, I can't copy and paste it, but we get the idea of how we would get that information, hopefully. Let's see what it's done with the stroke types. Okay, great. So looking here at the stroke types for patients with AF, here it tells me that most of these patients had MCA infarcts, 70% of them. You found other in a certain proportion. And now let's look at the patients without. Okay, so a different proportion, right? MCA infarcts 36.3, PCA infarcts 5. This is an interesting, probably small finding, but you know what? Why don't we, as a final step before we go, let's have a look at that. So, can you compare the proportion of patients with MCA infarct with versus without AF? Please tell me what statistical test you would perform, and tell me if the difference is statistically significant. using p threshold of 0.05. Let's see what it does here. Okay, so it's telling us it's using a chi-squared test, which is appropriate when examining a relationship between two categorical variables. Great, thank you. The null hypothesis in this case is there is no association between the occurrence of MCA infarct and the presence of AF, i.e. if we reject the null hypothesis, it would suggest that there is a statistically significant association between the two variables. So let's set up a contingency table, so like a crosstab to have a look. Let's see what it does. So again, for it to run the analysis, it imports the package that it needs to run the test. It creates groups of patients, so it gives labels of MCA with AF, MCA without AF, and it tells you how it calculates that. So it takes the discharge diagnosis of patients with AF, and then gets their MCA infarct count. Then it produces a contingency table, so a 2x2 square, and then performs a chi-squared value. It then tells us this. So I suspect what this is telling us is whether the p-value is less than 0.05 and what the p-value actually is. Then says, yeah, great. So the p-value of this, we reject the null hypothesis. So we can conclude that there's a statistically significant association between the occurrence of MCA infarct and the presence of AF in this data set. So, I just wanted to share that because to me, this is the sort of analysis that would take me, a day at least, if not longer, to do. And we've just sat here and I don't know how much time has gone past and gotten a good amount of information. So to summarize, what we have probably gotten for us to be able to write out. So if I was to, make some notes, what I would probably try and, what I would probably try and work towards is we had 179 patients. So if I have to present this at an audit meeting, we'd go through the age. I think it was something like 67. And of course, I'd refer back to the data here to see what it was. Age 67 plus minus whatever, I think 14. We could comment on the gender. We could comment on what their ECG findings were. So ECG findings, we'd bring that table in. And then you'd want to comment on the discharge diagnosis. Then in my next slide, I would talk about the different tests. What proportion, I think that was here. Yeah, so the different tests, and I'd calculate that as a proportion of our total number. Done. I'd probably produce a summary of the findings. Then, any other interesting things. I think that MCA infarct percentage. So let's see. Sorry, let me go back to the result here. So it says that there was a significant association, and what I would do is go back to those. So here and just pull that out, and of course, what I would probably do now offline is go through more aspects of this data and look for more patterns and analysis there. But let's pull this in. So this is for patients without AF. And then patients with AF. And what we know is that p-value was 0.0003. So I'm going to say, let's just say, that would probably be another finding. And then I'll keep building out my presentation there. So I hope you guys find this exciting and interesting. I think it's going to change the way that we look at our data, and I'm going to be going through lots of other data sets as part of my PhD and research. And if you want to join along and me to do it in a shared way, of course, if it can be done whilst preserving the anonymity of the data, then please drop me a message and I will try and make more videos like this.